Lockheed State Route 71 Blackbird. The iconic State Route 71 Blackbird spyplane is known for being the official record holder for the fastest jet-powered, piloted aircraft of all time. No reconnaissance aircraft in history has operated globally in more hostile airspace or with such complete impunity than the State Route 71, the world's fastest jet-propelled aircraft. The Blackbird's performance and operational achievements placed it at the pinnacle of aviation technology developments during the Cold War. The Lockheed State Route 71 and Quat, Blackbird and Quat, is a long-range, high-altitude, Mach 3 strategic reconnaissance aircraft developed and manufactured by the American aerospace company Lockheed Corporation. It was operated by the United States Air Force, USAF, and NASA. The State Route 71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft during the 1960s by Lockheed's Skunk Works division. American aerospace engineer Clarence and Quat, Kelly and Quat Johnson was responsible for many of the aircraft's innovative concepts. The shape of the State Route 71 was based on that of the A-12, which was one of the first aircraft to be designed with a reduced radar cross-section. Initially, a bomber variant of the A-12 was requested by Curtis LeMay, before the program was focused solely on reconnaissance. Mission equipment for the reconnaissance role included signals intelligence sensors, side-looking airborne radar, and a camera. The State Route 71 was both longer and heavier than the A-12, allowing it to hold more fuel as well as a two-seat cockpit. The State Route 71 entered service in January 1966. During aerial reconnaissance missions, the State Route 71 operated at high speeds and altitudes Mach 3.2 and 85,000 feet, 25,900 meters, allowing it to outtrace or entirely avoid threats. If a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outpace the missile. On average, each State Route 71 could fly once per week due to the extended turnaround required after mission recovery. A total of 32 aircraft were built. 12 were lost in accidents with none lost to enemy action. During 1989, the USAF retired the State Route 71 largely for political reasons. Several were briefly reactivated during the 1990s before their second retirement in 1998. NASA was the final operator of the Blackbird, who used it as a research platform, and was retired in 1999. Since its retirement, the Senior 71's role has been taken up by a combination of reconnaissance satellites and unmanned aerial vehicles, UAVs, a proposed UAV successor. The State Route 72 is under development by Lockheed Martin and scheduled to fly in 2025. The State Route 71 has several nicknames, including an Quat, Blackbird and Quat, and an Quat, Habu and Quat. As of 2022, the State Route 71 holds the world record it set in 1976 as the fastest air-breathing manned aircraft, previously held by the related Lockheed YF-12. This Blackbird accrued about 2,800 hours of flight time during 24 years of active service with the U.S. Air Force. On its last flight, March 6, 1990, Lieutenant Colonel Ed Yielding and Lieutenant Colonel Joseph Feeder set a speed record by flying from Los Angeles to Washington, D.C., in 1 hour, 4 minutes, and 20 seconds, averaging 3,418 kilometers, 2,124 miles. per hour. At the flight's conclusion, they landed at Washington Dulles International Airport and turned the airplane over to the Smithsonian. Twin-engine, two-seat, supersonic strategic reconnaissance aircraft, airframe constructed largely of titanium and its alloys, vertical tail. Fins are constructed of a composite, laminated plastic-type material, to reduce radar cross-section. Pratt & Whitney J58, JT11D20B, turbojet engines feature large inlet shock cones. Dimensions overall, 18 feet 5 and 15/16 inches by 55 feet 7 inches by 107 feet 5 inches, 169,998.5 pound. 5.638 meters by 16.942 meters by 32.741 meters, 77,110.8 kilograms. Other, 18 feet 5 and 15/16 inches by 107 feet 5 inches by 55 feet 7 inches. 5.638 meters by 32.741 meters by 16.942 meters. Materials titanium. But what does the State Route 71 actually owe its speed to? Its engines. The two black pods on each side of the flight body are as complex and thought through as the rest of the aircraft. They consist of two Pratt & Whitney J58 engines, which were at the time the only American engines built to continuously use afterburners, which is why the State Route 71 consumes so much fuel. Just like previously mentioned with the flight body being built for extreme speeds, so were the engines with their ultimate cruising speed at Mach 3.2. When going supersonic, the air going into the engine is traveling at supersonic speeds, resulting in shock waves inside of the engine which might lead to engine failure. To get rid of this problem, the inlets to the engines on the State Route 71 are blocked by a big pointy piece of metal, called a spike, which moves forward and backwards depending on how fast the aircraft is flying. When flying at top speed, the spikes could retract as much as 66 centimeters into the engine, changing the speed of the incoming air to a subsonic 0.5 Mach. It does this to keep the air pressure inside of the engine constant. The same idea is used on, among others, by the Soviet Sukhoi Su-22 fighter. However, sometimes when going supersonic, the engines failed in changing the pressure of the incoming air, which led to only one of the engines going supersonic. The result of this is heavy yawing, which can only be solved by restarting the engine. However, often both of the engines were restarted to be sure that the yawing stopped. The energy of the shock waves at the spike, plus the heat produced by the constantly used afterburners, heated up the compressors to temperatures of over 400 degrees Celsius. Actually, the maximum temperature the engine compressors could work at, 427 degrees Celsius, was what limited the speed of the Blackbird. However, studies made in the later years of the 20th century showed that with the right materials, engine inlets of the State Route 71 type could theoretically work at speeds as high as Mach 6. But even though the Blackbird was so expensive and hard to build, it did get onto the production line, and it was an enormous success. Not only was it black, had been a secret project and looking like it was from another planet, it was the fastest aircraft the world has ever seen. And more importantly for the US, it was faster than anything the Soviets had ever built. Although it carried electronic countermeasures, the main defensive system of it versus missiles was simply to outrun them. Just like quoted from the State Route 71 Blackbird documentary on PBS, if a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outfly the missile. The effectiveness of this defense was proved in 1981 when Kelly Johnson, one of the designers of the Blackbird, announced that over 1,000 missiles had been launched towards the State Route 71. But none of them had hit. Out of the 32 senior 71s that were built, 12 were lost due to accidents. Never because of enemy fire. While talking about weapons and countermeasures, it is needed to say that the State Route 71 was never fitted with any weapons. Of course, this was due to many reasons, but one was that it was simply not built to shoot. It was built to survey and take pictures, and since it could not, in practical, be shot down, it had no need to be fitted with weapons. The Blackbird was only capable to fly for approximately 5,400 kilometers, which may seem like a lot, but compared to the Lockheed U-2, another reconnaissance aircraft, with a range of over 10,000 kilometers, it is very inferior. The short range, which was a result of the very thirsty engines, was the reason for the in-air refueling capability to be fitted with the State Route 71. It flew so high and so fast that the crew needed pressurized spacesuits when flying it. And it is said that at the maximum altitude of it was possible to see the curvature of the Earth, which refers to this quote by Colonel Allison, "On a clear day you can see forever." The service ceiling of 85,000 feet, 25,900 meters, meant that it was an excellent experimental unit for space travels. That, combined with the great speeds of it, was two of the reasons why NASA decided to take over the last two Blackbirds after its retirement from the Air Force in 1998. This means that the world's fastest aircraft was in service from 1966 until NASA retired its two units in 1999, and most of the remaining Blackbirds are today stationed at museums or military bases across the U.S. Since the dawn of these airplanes, there have been countless missiles and other rocket-propelled aerial vehicles moving faster than Mach 3.3, but there has never been a manned, air-breathing one. We do not know if there will be one in the future, and given the recent developments with UAVs, it looks unlikely, but we do know that when the Blackbird entered service with the U.S. Air Force, it was cooler, faster and more astonishing than the world had ever seen before. Gathering information about the enemy while flying at an altitude of 20,000 meters at speeds as high as 3 times the speed of sound is a true proof of the skill of American Skunk Works engineers. Just being able to accelerate away from a surface-to-air missile and use that feature as a main defense is a huge accomplishment on its own. The Lockheed State Route 71 Blackbird will therefore reserve a special place in most aviation lovers' heart. The Lockheed State Route 71, designed in secrecy in the late 1950s, was able to cruise near the edge of space and outfly a missile. To this day, it holds the records for the highest altitude in horizontal flight and the fastest speed for a non-rocket-powered aircraft. It was part of a family of spy planes built to venture into enemy territory, without being shot down or even detected, in a time before satellites and drones. The black paint job, designed to dissipate heat, earned it the nickname Blackbird, and paired with the sleek lines of the long fuselage, made the plane look unlike anything that had come before, a design that hasn't lost any of its brilliance. In May 1960, an American U-2 spy plane was shot down in Soviet airspace while taking aerial photographs. Initially, the U.S. government said it was a stray weather research aircraft, but the story fell apart once the Soviet government released photos of the captured pilot and the plane's surveillance equipment. The incident had immediate diplomatic repercussions for the Cold War and reinforced the need for a new type of reconnaissance plane that could fly faster and higher, safe from anti-aircraft fire. And quote, the CIA wanted a plane that could fly above 90,000 feet or thereabouts, at high speed and as invisible to radar as it was feasible, unquote, said Merlin. The task of designing such an ambitious machine fell on Clarence and Kelly and Johnson, one of the world's greatest aircraft designers, and his secret division of engineers at Lockheed, called Skunk Works. And everything had to be invented. Everything, and recalled Johnson, who died in 1990, the same year the Blackbirds were first retired from service. The original plane in the Blackbird family was called the A-12 and made its maiden flight on April 30, 1962. In total, 13 A-12s were produced, and the plane was a top-secret, special access program operated by the CIA. Titanium skin because the aircraft was designed to fly faster than 2,000 miles per hour. Friction with the surrounding atmosphere would heat up the fuselage to a point that would melt a conventional airframe. The plane was therefore made of titanium, a metal that was able to withstand high temperatures while also being lighter than steel. Using titanium presented other problems, however. First, a whole new set of tools, also made of titanium, had to be fabricated, because regular steel ones shattered the brittle titanium on contact. Second, sourcing the metal itself proved tricky. And the USSR was, at the time, the greatest supplier of titanium in the world. The U.S. government had to purchase a lot of that, probably using bogus companies, and said Merlin. The initial aircraft were flown completely unpainted, showing a silver titanium skin. They were first painted black in 1964, after the realization that black paint, which efficiently absorbs and emits heat, would help lower the temperature of the entire airframe. The Blackbird was born. The fuselage of the State Route 71 included some of the very first composite materials ever used in an aircraft, which made the plane harder to spot for enemy radar. And it was essentially stealthy before the word stealth was even used. And said Merlin. Flying at a higher altitude than anti-aircraft fire could reach, faster than a missile, and barely visible to radar, the Blackbird could enter hostile airspace practically undisturbed. And the idea was that by the time the enemy detected it and fired their missile, it was already on its way out. And Merlin explained. And but this was before we had real-time data links, so they were taking pictures on film and bringing the film back to base to be processed and studied. And as a result, no Blackbird was ever shot down by enemy fire. However, its reliability was an issue, and 12 out of 32 were lost to accidents. It was also a complicated plane to operate and fly. And it took an army of people to prepare the aircraft. A Blackbird operational mission essentially had a countdown, like a space mission did, because there was so much preparation involved in both getting the crew ready and the vehicle ready, an unbelievable amount of effort and manpower, and quote, said Merlin. The pilots also had to suit up in a special way, due to the extreme conditions found at high altitude. And quote, they basically wore a spacesuit, the same sort of thing that you would later see space shuttle crews wearing, and quote, said Merlin. And quote, the cockpit also got very hot when flying at high speeds, so much that pilots used to warm up their meal on long missions by pressing it against the glass. And quote, no Blackbirds were ever flown over Soviet airspace, something the U.S. government stopped doing entirely after the 1960 incident. But they still played an important role in the Cold War, and performed missions in other critical theaters such as the Middle East, Vietnam and North Korea. In 1976, the State Route 71 set the records it still holds, flying at a sustained altitude of 85,069 feet, and reaching a top speed of 2,193.2 miles per hour, or Mach 3.3. The program was halted in 1990, with a brief revival in the mid-1990s, once technologies like spy satellites and UAVs, unmanned aerial vehicles or drones, had become more feasible and offered instant access to surveillance data. The State Route 71 was last flown by NASA in 1999, which used two of the aircraft for high-speed and high-altitude aeronautical research. Since then, the surviving Blackbirds have all found their way into museums. No reconnaissance aircraft in history has operated globally in more hostile airspace, or with such complete freedom than the Lockheed State Route 71 Blackbird. With a futuristic organic design that originated back in the 1950s, it remains the world's fastest jet-propelled aircraft more than 2 decades after its final retirement. The Blackbird's performance and operational achievements placed it at the pinnacle of aviation technology developments during the Cold War. In May 1960, the CIA were flying the Lockheed U-2 spy plane. Lockheed themselves were already working on their submitted proposal for a new reconnaissance aircraft, codenamed A-12, that would fly faster than any aircraft before or since, at greater altitude, and with a minimal radar cross-section, avoiding interceptors and missiles. However, the 1960 U-2 incident, when Francis Gary Powers was shot down in Soviet airspace, ruthlessly reinforced the vulnerability of the subsonic U-2 and spurred on the development of the A-12. Lockheed's clandestine, Skunk Works division, headed by the gifted design engineer Clarence L. and Quat Kelly and Quat Johnson, worked on the A-12, attempting to develop an aircraft, for which everything had yet to be invented, in just 20 months. The A-12 was designed to cruise at Mach 3.2 and fly well above 60,000 feet, 18,288 meters. To meet these challenging requirements, Lockheed engineers overcame many daunting technical challenges. Titanium alloy was used to build the airframe, combating the extreme external heat that would melt conventional airframes when traveling at 3 times the speed of sound. Special titanium tooling was fabricated when it was realized conventional tools embrittled the metal alloy on contact. A complex air intake and bypass system was designed for the twin afterburning turbine engines to prevent supersonic shock waves from moving inside the engine intake, causing flameouts. Later in development, Black paint was applied to the exterior of the aircraft to dissipate the heat across the entire airframe, earning the A-12 its nickname, Blackbird. The U.S. government requested an even smaller radar profile, so a radar-absorbing element was added to the paint, whilst the airframe was carefully reshaped to reflect as little radar energy as possible. This treatment became one of the first ever applications of stealth technology. The original single-seater A-12 Blackbird made its first official test flight on April 30, 1962, not counting an unintentional liftoff the week prior during high-speed taxi trials. Experience gained from the A-12 program convinced the Air Force that flying safely required 2 crew members, and the design evolved into the larger State Route 71, the senior standing for strategic reconnaissance. The State Route 71 had room for a pilot and a reconnaissance systems officer, RSO, who would operate the wide array of monitoring and defensive systems installed on the aircraft, including a sophisticated electronic countermeasures (ECM) system that could jam most acquisition and targeting radar. After the Senior 71's first flight on December 22, 1964, the Blackbird nearly broke records every time it flew. In 1976, the State Route 71 set the records it still holds to this day, flying at a sustained horizontal altitude of 85,069 feet, 25,929 meters, and reaching a top speed of 2,193.2 miles per hour, 3,529.6 kilometers per hour, or Mach 3.3, the fastest speed for a manned and non-rocket-powered aircraft. At that speed and altitude, even the best air defense systems had no hope of catching the Blackbird. Piloting the Blackbird was an exacting endeavor, requiring a full operational staff for each mission and demanding complete concentration from all involved, much like a space mission did. Pilots were giddy with their complex, adrenaline-fueled responsibilities, with one describing the act of flying the Blackbird as almost a religious experience. Zooming across the sky at 3,000 feet per second required the rules of navigation to be rewritten. Visual references for conventional flying, like roads, rivers, and urban areas, were rendered obsolete, giving way to mountain ranges, coastlines, and large bodies of water. The pilots also wore specialized pressure suits, similar to those of astronauts. Due to the extreme conditions found at high altitude, these suits were required to protect the crew in the event of sudden cabin pressure loss while at operating altitudes. The State Route 71 was retired twice in the 1990s, after a brief politicalized reactivation in 1995. In total, 50 Blackbirds were built, 32 in the State Route 71 variation. 13 original A-12s were also constructed, including one training variant nicknamed the Titanium Goose, together with 2 of the M21 variant, which carried unmanned drones, and 3 YF-12 prototype interceptors. Most importantly to the U.S. government, the aircraft delivered on its strategic responsibilities globally, providing the United States detailed, mission-critical reconnaissance for more than 2 decades across a number of theaters. Only a select few know the true extent of the role the Blackbird's intelligence played in the Cold War, but it is known that the Blackbirds and their crews provided information that proved vital in formulating successful U.S. foreign policy on many occasions, particularly in the Middle East. filling the intelligence gaps left from the orbiting reconnaissance satellites. Its legacy, as a technological masterpiece, will be admired for generations to come. This fine-scale model will be based upon U.S. Air Force State Route 71A, SN-61, 17972, as it was on its record-breaking final flight in the hands of pilot Lieutenant Colonel Ed Yielding and Reconnaissance Systems Officer Lieutenant Colonel Joseph Vida. SN-61, 17972 accrued about 2,800 hours of flight time during 24 years of active service with the U.S. Air Force. On its last flight on March 6, 1990, Lieutenant Colonel Ed Yielding and Lieutenant Col. Joseph Vida set a speed record by flying from Los Angeles to Washington, D.C., in 1 hour, 4 minutes, and 20 seconds, averaging 2,124 miles per hour, 3,418 kilometers per hour. At the flight's conclusion, they landed at Washington Dulles International Airport and turned the aircraft over to the Smithsonian. It is now exhibited at the Stephen F. Udvar-Hazy Center in Virginia. At that time, Lieutenant Colonel Vida had logged 1,392.7 hours of flight time in Blackbirds, more than that of any other crewman. Designed and assembled completely from scratch in our Bristol workshop, this model is the result of a powerful combination of art and technology. The use of technical drawings and archival imagery have allowed us to perfectly recreate every detail at scale to create a model indistinguishable from the real aircraft in photographs. Individual panels and finishes were extrapolated from original technical drawings and images of the plane exhibited at the Stephen F. Udvar-Hazy Center in Virginia. 3D printing technology is used to produce the majority of the components. Before our model makers used traditional machining and hand-working techniques to create the most precise, accurate and faithfully detailed pieces. Multiple paint techniques and materials have been used to accurately replicate real-life pagination. It will be reproduced at 1/40 scale, meaning the model will measure 820 mm long. The model will be mounted as if in flight, held above a base by aluminum columns.